So welcome to this edition of Seen and Solved. I'm Tim Pennington, your host. And, the last couple of months, a lot of EPA regulations around solvents seems to be coming down the pike month after month, it seems like. And it's getting more stringent. And I'm sure it's causing manufacturers to think, what can they do to clean their parts? Today, we have two people with us who are going to help us explain that, explain it to manufacturers and processors.
You're listening to the Seen and Solved podcast, brought to you by Hubbard-Hall. Better results, less chemistry.
Today, we have Jeff Beard, the Product and Business Development Manager for JAYCO Cleaning Technologies. And we have Mike Valenti, Director of Cleaning Technologies for Hubbard-Hall. Welcome, gentlemen.
Hello.
Hello.
Yeah, so when we talk about cleaning, it seems like in the last 6 or 7 months, it's coming out like a fire hose with a lot of what EPA regulations and moving parts of what's going to be allowed and what's going to be maybe discontinued and such. But before we get to that, let's talk a little bit about how you all have come to kind of work together a little bit. Seems like there's some energies between Hubbard-Hall products and JAYCO Cleaning Technologies. Talk us a little about that.
When I normally speak about this specific subject, which is people that want to move away completely from solvent degreasing to aqueous cleaning, one of the things I always talk about is, as a chemical supplier, there are certain problems we can solve with the chemistry, but the chemistry itself can't compensate for all the properties you need to clean with aqueous solutions. So equipment is another side of the equation that you need, because you need different types of equipment to get the same result you're getting with solvent in a degreaser today. So it takes not just chemistry, but the proper equipment to be able to make that conversion. And so that's why, working with Jeff, it's important that we talk about this as a process replacement and not just chemical replacements.
Yeah, same thing, Jeff. I guess, like I said, you all make the equipment. It's really a lot to do with the chemistry that's going to be utilized in it, correct?
Absolutely. I think that Mike and I get along really well in this subject. He mentioned process, and at the end of the day, this is absolutely about the process. It's about mixing and matching a chemistry to the soils, and then that chemistry to the piece of equipment. And the chemistry and the equipment today have to work together. And it's incumbent upon us as suppliers, both of us, both of our companies, to provide that knowledge and information to customers, so that they understand, why is this chemistry the best for my materials compatibility as well as soil removal, and then how is it going to operate in this washer that I'm looking at? And, unfortunately today, when we all got in this business a long time ago, there was specific cleaning people, dealt with cleaning every day, the cleaning guy, so to speak. Unfortunately, that guy, not a lot of those people today specifically are able to focus only on cleaning. They rely on Hubbard-Hall, they rely on JAYCO to provide that knowledge and the process.
Yeah, like I said, it's kind of a marriage of the two: technology, the equipment, and then what's being used to help run that equipment. But Jeff, to walk us through a little bit about the technology behind the JAYCO's rotary basket parts washer. I know it's a kind of a really nice footprint for a facility, but walk us through all the components and what it does.
Sure. So I've been calling these Aqueous single chamber vacuum cleaning systems. These systems today really are taking a lot of the standard technology that's been used in equipment and combining it all into one system. So within a system, we do spray, we do flood, we do immersion with or without ultrasonics, and then we add vacuum to that, which we can use to enhance the cleaning and rinsing process, as well as vacuum drying. So, these systems today have lots of technology added into them, which makes the process highly effective as we look at the broad range of soils, as we look at cleaning 3D printed parts. because of the vacuum, we're able to do a much better job of cleaning than we could with standard immersion ultrasonics or just a spray washer.
So let's go to Mike. I mean, what type of Hubbard-Hall chemistry would you pair with this type of equipment, and why would you use that type?
So one of the benefits that solvent degreasing has always had is the cleaning agents, the solvents, are universal. So for example, if I've got brass parts, steel parts, aluminum parts, I can put all those parts in a degreaser, whether it's vacuum or vapor, and I can clean all those different alloys with one solvent system because the solvents don't react with the metals. They're compatible with all the metals. So when we talk about the types of chemistry, we want to make it as close to that as possible when people go to aqueous cleaning, to give them, again, a single chemistry, because that's what they're used to, right? So with most aqueous cleaning systems, if you don't have some of the technology that JAYCO has put in, you might need separate tanks. You might need more than one wash process because you got to wash different incompatible alloys and the chemicals. So what we're looking to do is put chemistry in that is, first of all, we don't want to replace one hazard with another. So we want to put chemistry in there that's got low hazards, okay, that can clean all metal types safely without attack. We want to be able to separate the soil. So we want chemistries that help remove the soils from the cleaner bath. And because we are now counting on a lot of more mechanical action to do the cleaning, spray, and ultrasonics, the flooding, we have to have low foam profiles because now we're doing a lot more agitation. We're doing a lot more mechanical, what we call mechanical cleaning. So we really want cleaners that are environmentally safe to workers, because we don't want them to trade one hazard for another. And we want something that's universal, just like solvents are universal, because that makes the transition for those customers a lot easier if they have one cleaner that they can use to clean all their parts. So our goal is to have cleaners that specifically meet all those criteria. The other thing is that's really important in solvent cleaning. One of the other benefits is the parts come out of the degreasers residue-free, because the solvents themselves don't have any components that can leave a residue behind on the surface. So we want aqueous cleaners that also rinse very easily and don't leave a lot of excess residues, because in medical applications, specifically, if you have residue on the parts, they're not going to be able to tolerate that. So the other thing we want is leave nothing behind on the parts as well, if possible.
Jeff, I was looking at your site. You guys got some really nice photography of this equipment. Nice footprint, like I said, all really there. Tell us how this is different from other solvent equipment options. Like I said, considering price and footprint and those type of things. Sure.
If you were to look at this technology, it's all confined within a box, much like the vacuum vapor degreasing systems that have become so popular today in the U.S. Our difference is we use aqueous technology versus some solvent, whether they're using modified alcohol or the hydrocarbons. We're using the aqueous media. So similar, footprints. The really big difference between the two processes, if you were to compare them, is the temperature of the parts coming out of the process. The parts coming out of the aqueous process are 94 to 95 degrees Fahrenheit at the skin temperature. So customers are able to handle those parts virtually immediately because the parts are not too hot to touch. where with the vacuum vapor degreasing processes, those parts are coming out exceptionally hot and require time to cool before they can move on through the process.
Not good for throughput, right? Not good for quick throughput on certain things, right?
Not good for throughput. And if you have parts that are sensitive to measurement, right, if they have to have specific, measurements, that heat can affect those measurements. Again, requiring more cool time. So we're really able to push a lot more parts through the process because it's in and out. It's push a button, the door opens, closes, parts go in dirty, come out clean and dry. Obviously a vast oversimplification of the process, but we're able to do that in a 10-15 minute process, depending upon the parts and the soils and all those things. So it's a very similar to a solvent process, but again, aqueous. And I think this is, again, the technology. Aqueous cleaning has been viable since Freon went away 30 plus years ago. The aerospace industry did a really good job of going to aqueous cleaning in immersion processes or cabinet washers a lot, typically. But aqueous, I think, has always run into this problem of the drying. How do I dry my parts? And as industry has miniaturized components with 3D printing, with the chamber, very small, intricate chambers, what they're able to do with printing today, it really, aqueous, some might look at aqueous and say it's just not viable for these really high-end miniaturized processes. When in fact, with this technology today, because of the vacuum, we're able to clean all of those parts that in the past generally would have been considered a solvent-only process.
Yeah, options are great with that. And Mike, how's this different from other solvent alternatives? I know we've read a lot about modified alcohols and those types of things, but how is it different?
Well, so the modified alcohol specifically, they work, first of all, you can only use those in a vacuum degreaser, right? So you cannot replace, so someone that's doing vapor degreasing and wants to replace that equipment, their capital cost to replace that piece of equipment with a true vacuum system designed to run modified alcohols is going to be extremely high, much higher than, say, the technology JAYCO is offering, because the engineering required to recycle the solvent is, and the compatibility of seals is much higher. Modified alcohols, like all solvents, won't clean everything well. They clean some things very well, and there's certain things they don't clean well. So what we're talking about now is and we don't know what the future holds for any solvents, right? So the day they ban water, we're all in trouble, right? So what we tell customers, when they ask and call, they say, well, can you guarantee me that if I switch to an azeotrope solvent or a modified alcohol, that those are not going to be regulated in 5 to 10 years? And what I tell them is I can't guarantee you that, because the EPA's bias is still to try to eliminate solvents. So moving someone to aqueous cleaning directly solves that problem. So really, technically, yes, do they clean? Yes. Is the equipment viable? Does it work? Yes. But if somebody really wants to move away and take the risk out of their operation in the future, not knowing what the next regulation is going to be, then move to water-based cleaning. So to me, that's the biggest thing. The biggest difference is really the risk in the future. You make the change to water-based cleaning, now you don't have to worry about what solvent regulations coming down the pike in 5 or 10 years. You're asking someone possibly to make a 6-figure at least investment in a new vacuum system, and you can't guarantee that in 5 or 10 years they're not going to have to replace it again, right? So why not go ahead, if you're gonna make that investment, make it into a system is going to last for a long time.
Right, not on anybody's radar to be studied and maybe removed with that.
Then the only true risk is, what chemistries do they regulate in aqueous cleaning? Well, we have a lot more options to offer in aqueous cleaning than there are solvents. So there's going to come a point where they regulate salt. There aren't going to be any non-regulated solvent options possibly. But aqueous cleaning, we have a lot more tools in our toolbox to make formulations that we can offer that answer any type of regulatory concerns.
I think that's the great thing that the chemical industry has really done, is marched forward with technology as well. The surfactants and technology available for Mike and his team to make chemistries with has changed so much in the past few years. It helps with the soil removal. It helps with the oil splitting. The environmental impact, second to none today compared to the old chemistries, if you will, right? So the technology on the chemistry side has changed every bit as much as on the equipment side. And I think that's why it's working so well together today for this type of process. To what Mike said with, talking to customers trying to get out of vapor degreasing, open tops, I talk about short-term and long-term. For the short-term, sure, a trans blend of some sort is absolutely likely better than using trichloroethylene or N-propyl bromide. But long-term, as a chlorinated solvent, those solvents, the way the EPA is acting today, likely have a shelf life. And look at the long-term, plan budgeting, plan the testing required to make a process change so you have time to do it. So you don't have to do it real quick when the ball drops and then you're 100th in line, because that could honestly happen. There's only so many manufacturers of equipment. The line is going to get long if it really goes bad for solvents.
We mentioned water, and I had a shop owner tell me one time the most expensive chemical he uses is water, right? He uses a lot of it sometimes. What do you say to people who are concerned about the amount of water that sometimes is used in this equipment, or is there a concern?
So these systems have oil removal integrated into them. So assuming that the oil is able to be split, straight oils, you can split, and your life of your chemistries is going to be significant because we're doing filtration and oil removal, which greatly extends the life of those chemistries. On the rinse side, we can implement simple carbon ion exchange systems into the process and reuse rinse waters. So, the days of water coming in and immediately going out to drain, I think that's all. I understand there's a lot of places that still do that, maybe in plating, but with this type of process, we're doing all we can to really mitigate waste, if you will. We want the chemistry to run as long as we can. We want the rinse water to use as little as necessary. And again, having chemistries built for this type of equipment that are effectively rinsed, that means we have less water usage during the rinse process, which means we're going to use less water overall. So it really does all work together truly synergistically today, the way these processes are put together.
Yeah, and you mentioned long-term solutions. Is this something you all both take assumption that this is really the best safe long-term solution that's out there, right?
It is, because there's an unknown. So when customers or prospects call me and tell me what's going to happen to solvents in 5 years, my answer is I don't know. What we do know is the EPA has made it clear that they will, whatever the replacement is so let's say let's just say that modified alcohols becomes the global standard for replacing TCE and vacuum degreasing. Okay. Once enough people start using that and the volumes are significant, they're going to start looking hard at that, because that's their job, is to look at what are people using and what are the risks associated. They're always going to be doing a risk assessment on whatever people are using, whatever the highest volume product is. So we don't know the answer to that question, but we do know that aqueous cleaning, from a environmental standpoint, if we're not dumping stuff down the drain, which is easily controlled, right? Like Jeff said, if someone today wants to do zero discharge of water, we have customers that discharge even outside of Jeff's type of equipment. They can discharge zero water. There's a cost associated with that. But if that's a concern, there's a lot of technology available to deal with recycling water, right? But we know that water vapor coming out of Jeff's machine is not going to be an issue that the EPA is ever going to be concerned about. But organic solvents, any of them at some point, could get on their radar and could be regulated, but we don't know the answer to that. So it's a risk.
Yeah, I was gonna say it's that risk hanging over those people, and it's something I know a lot of owners, a lot of manufacturers just don't want the risk. They don't want that.
So we have customers. We have a lot of customers that do standard, just regular vapor degreasing in a chamber, a vacuum chamber. And they'll call me and they'll say, and let's say they're running TC, and they'll say, what's the replacement? And I'll say, well, if you don't want to buy new equipment, maybe it's one of these, fluorinated blends. And then they'll say, well, can you guarantee me? I say, all I can guarantee you is they're going to clean the parts. And they say, well, what if I just don't want to deal with solvents at all? So we hear this, like, just get me. Sometimes I hear this, well, just get me out of solvents completely, okay? Well, if I hear that, then I know that I can't just sell them a cleaner that's going to get them out of solvents, right? So then it's like, okay, they need equipment that's going to be able to help them do all the other things they need to do to get the same level of cleanliness. So that's usually my answer to people. And there are people that just flat out say, I don't want to have to worry about this ever again. Help me get out of it. So that's where working with JAYCO, that's where the rubber meets the road here, because we can't do it by ourselves.
And it's funny, Jeff, you mentioned earlier, the person that was in charge of cleaning and things like that, and you don't see that anymore, right? It's a sort of a communal responsibility. And it seems like systems like this would really help with the support and technology support and service that you guys provide. Really makes it easier for these facilities to have this type of equipment, right? I mean, they don't have to find somebody who's a specialist in this and hire this person to come and do this. It's really something that I think it makes it a simpler process for them overall to run.
Jeff talked about how in vapor degreasing or vacuum degreasing, people put a basket in and they push a button and then the parts just come back clean. Well, that's what they expect, right? So if you move them to an aqueous system and now they have all this complexity and all this extra stuff they got to monitor and do, it's very difficult. So if you have an aqueous system where they put the basket in, push the button, and the parts come out clean and dry, to them, it doesn't really, in the end, they don't care what the solvent is in the system. In this case, the solvent is water, right? They just want clean parts. So the easier you can make it to push the button and the basket comes back out with clean parts, the more likely they are to listen to you.
Right. Integrate this into their system. Right. Yeah. Especially with, like I said, it's tough. Workforces are tougher to hire for some people. They're looking for that, the people and cross-train just to kind of come in and not be an expert, but be able to manage that system that's there. So it seems like it's a very viable solution for a lot of facilities that may be needing this. Absolutely.
I think that, and again, going to the technology and talking about, maintaining, we let technology do that today. So we integrate conductivity meters into the rinse water to monitor the rinse water for, set levels for cleanliness to customer requirements. With the chemical part of it, we do automatic chemical feeds, again, monitored by conductivity. So we've done as much as we can to take the worker, if you will, out of having to do a lot of hands-on with the process to make it as easy as possible. So you have the system monitoring everything that needs to be monitored. The people literally bring the basket to the system, push the button, walk away, come back when it's done. And that part of it, because it's easy to train someone for that, right? So with today's worker shortage still, kind of unbelievable today, companies are able to really easily cross-train. If the person that usually does this job isn't here today, you can easily bring someone else in to do this because the training is pretty quick and simple. Push the button, right?
Right. There you go.
Yeah, there's another pattern we see. So a lot of big facilities in the past, let's take a shop that's machining brass parts, machine brass, right? They'll have all their CNC machines in a room cutting all these parts, and they'll have a giant washer somewhere in another room across the plant, and all these parts go to this big washer or degreaser, whatever the system is, and they're cleaning everything through there. And they, if they have downtime, if they have problems, then that becomes a bottleneck typically, right? So one of the things we see now is people now are starting to say, we're going to clean these parts. We're going to do it in a cell configuration. So we've got 2 or 3 machines cutting parts, and they want a system right there that the parts then go in, they're cleaned immediately, right? They don't sit around. So instead of having these giant washers, they're trying to clean everything. They build cells because it reduces, the time that the lubricant's on the parts, which can be a problem. It reduces labor transporting the parts around, and you need more compact systems to do that. So these types of systems lend themselves for this cell manufacturing, where they really want to do everything in a cell together. Want to machine them, clean them, they're ready to go to whatever else, whether they're packaged or they go get plated somewhere else or whatever. So you don't have a giant cleaning department anymore that you're hoping can get all these parts through these giant washers. So this type of technology, because it is more compact, it uses less water, you don't need long series of tanks, lends itself more to this lean type of manufacturing process.
Yeah, and we have a customer taking it a step farther and integrating a robot into the middle of that cell, and literally the robot moves the parts through the entire process. So, that's going to continue robots in manufacturing are going to continue to advance the capabilities, and I think we'll see a lot more of the cell specifically with robots being integrated.
Smart cleaning. Who would have thought, right? There you go. Well, listen, I appreciate it. Thank you all. This is sounds like a very good partnership of working with Hubbard-Hall and also JAYCO Cleaning Technology. So, Jeff and Mike, I certainly appreciate you taking time out and explaining that to us all. Thank you.
Yep. Thank you.
Thank you very much. Appreciate it.
The Seen and South podcast is brought to you by Hubbard-Hall. For more podcasts, visit Hubbard-Hall.com or wherever you get your podcast. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Aqueous.